Now, after all those expansions, it's probably time to go and look what the formula sheet actually gives us. So it's going to go with this question. What is the third term in the expansion of 4b minus 5 all to the power of 6? So if you imagine the last question, trying to do the full binomial expansion, it's going to take way too long for a question like this. We only care about the third term. We don't care about the rest of it. And the formula sheet does have something to help you. So it's t, and then k plus 1 is equal to n choose k, and then times x n minus k, and y to the power of k, which seems pretty complicated. The first part we're going to deal with, though, is what this n and this k are, and then we'll get why this is a plus 1. If we think about Pascal's triangle and how it relates to combinations, so if I want the first term of the sixth, or to the power of 6, so that'd be the seventh row, it's going to be 6 choose 0. That gets me my first term. My second term is going to be 6 choose 1. But we want the third one, so it's going to be 6 choose 2. So what's important to realize then is that this value that we're looking for is actually always one less than the term number we actually want, because we start at 0, not 1. So that's a very, very important distinction that we have to make. So when I go and put this in this formula, n in our case is 6, which is going to represent our exponent here. So then we're going to go 6 choose. Now k is always going to end up being 1 less than what term we're looking for. Okay, so it's going to be 2. Now the formula sheet kind of shows this the other way, because here we want term 3. So I'm just going to write this a little differently. So we want term 3, and that's going to be equal to tk plus 1 to get the term number. Well, that means 3 is equal to k plus 1, which means that k is actually equal to 2, which is what we put there. So it's a little bit confusing because this k value is always going to be 1 less than the term we actually want. We want term 3, so therefore the k value is going to be 1 less. And it's 1 less because with the combinations, we start at 0, not 1. Okay, now that we got that out of the way. Next, this x part. So if you remember, when I'm going and doing my expansion, we usually have that pattern where it goes like a to the power 4, and the next term is a to the power of 3, and then a to the power of 2, and so on. So the a value is always going down. So here, our n is part of this combination, so it's 6, minus the k part, which is 2. So here, and this makes sense, like if I start at 6, as a to the power of 6, and then I'd go down to 5, and then I go down to 4. Well, that whole time, the b value is going up by 1. So this is 0, then 1, then 2. So these numbers are actually related. Every time a goes down by 1, b is going up by 1. So here, if x is going down by 2, then that must mean that y went up by 2. And we have that in the formula as well, y to the power of k. Okay, so that's just all from the formula sheet. Now, I'd like to simplify this now before I do anything else. So 6 choose 2 is 15. And then this becomes x to the power of 4, y squared. And you might be thinking to yourself, oh, done, yes. Well, no, because this x is actually the first term of this. So this is my x, and this is my y. So I need to go and actually substitute the x and the y values in then. So it's going to become 15 times 4b to the power of 4. And then my y is negative 5. That negative is very, very important there. Well, maybe not so much this time because it's squared, so you get a little bit lucky. And then we can simplify as much as possible. So 4 to the power of 4 is 256. And then we get b to the power of 4, and the negative 5 squared is 25. So we can multiply all the constants, and we get 96,000 b to the power of 4. So that's going to be our third term of this expansion. Now that was a lot to take in, so let's do it one more time. what is the value of the fourth term in the expansion of 2a minus 7 to the power of 8? Okay, so I've already got the formula written for you. We are looking for the fourth term. So we're looking for the fourth term, which means that in our combination, k is actually going to be 3. It's 1 less. Okay, so in our combination, k is 1 less. Now, our n value is our exponent. So that's going to be 8. So our coefficient is 8, choose 3. Now for our x, well, we have an n of 8 and a k of 3. So it's going to be 8 minus 3. And then our y is just the power of k, which is 3. Okay, already way faster the second time going through this. So let's simplify 8, choose 3. We get 56. And then we get x to the power of 5 and y cubed. Next, x is actually this first term, and our second term is this minus 7, or sorry, the y is the minus 7. So I'm going to go and substitute those values in. So 56 times, now x is 2a, and that's going to be the power of 5, and then y is negative 7. Again, that negative is very, very important there. It is going to matter this time. We're going to end up having a negative answer because of that. So we're going to have, if we simplify this, we get 56 times 32a to the power of 5 times negative 343. Multiply all the constants, and you get 614,000 and 656 a to the power of 5. So much, much quicker the second time. All right, given 5x minus 2y to the power of 9, find the coefficient of the term containing x to the power of 5. All right, so we're not told the term number here, so we're going to have to base everything off this x to the power of 5. Now let's just double check, and it seems kind of mean, but is x actually in the x position? Yes, and y is in the y position. So we can just look at the formula normally. So we know x to the power of 5 is got to be equal to x n minus k. Well, in this case, our exponent is 9, so it's actually x to the power of 9 minus k. So therefore, because the bases are the same, we can just look at the exponent. So 5 is equal to 9 minus k. It's no one surprised k is equal to 4. Okay. Now, what term is that, though? If we go back to our formula, it says the term number is k plus 1, meaning we're actually in term 5. Okay. So don't make that mistake. Now for here then, so we got n choose k, so then it's going to be our n is 9, choose the k we said was 4, and then x, well we already know that's 5, and then our y value is our k, which is 4. Okay, so now we can go and substitute other values in and simplify this as much as possible. So 9 choose 4 is 126. 5x represents our x, so 5x to the power of 5, and then y is our negative 2y, so negative 2y to the power of 4. And then we can start doing some more simplification. So 5 to the power of 5 is 3,125, and that's times x to the power of 5. Negative 2 to the power of 4 is 16. So, and then y to the power of 4. And then we can multiply all of the constants. So we get 6,300,000. Oh, I cannot imagine doing binomial expansion, trying to figure this out. And then times x to the power of 5 and y to the power of 4. Now our answer is only the coefficient. That's all we want from this. So after all that work, that's our answer.